Okay, going ahead and getting started. We are finishing up. This is our last little lesson in this unit. We are talking about, again, still focusing on slope, but now we're going to focus on how we can compare slope within proportional relationships. So we talked about proportional relationships last semester, and that when you are graphing proportional relationships, they have two very distinct characteristics about them. Okay, we are able to look at a graph. I don't have this graph right now, but I would be able to look at a graph and immediately be able to tell that it's a proportional relationship because of two very specific details about the graph. Who can raise their hand and tell me what is one characteristic or rule that we need to follow in order to identify if a graph is proportional? EJ?
It goes through the origin.
It goes through the origin. Very good. So one of the rules, in order for it to be proportional, it has to go through the origin. Okay, it goes through the origin. And what's another characteristic? It goes through the origin, and it also has to be what, Jackson? Has to be a straight line. So in order for it to be a straight line, I'm going to say something different. Instead of saying it has to have a straight line, I'm going to indicate that it has a slope. A slope is a constant rate of change which creates that straight line. So it's going to go through the origin and it has a slope. Okay, and we know that it was written in a very specific format. We know that it was written in the format y equals kx. We had this formula y equals kx. Well, because of the fact that we now are talking about slope, we're going to change that variable k to a different variable. It's still the same formula, still the same, but instead of using the variable k, we're going to use a variable m, where m represents your slope. So we're going to write this down. Y is equal to m, I'm going to go ahead and put m in green since all my slopes have been in green. Y is equal to m, where m equals slope. So that's what we are now focusing on. We're focusing on those proportional relationships that go through the origin. So when I graph it, I know that I'm going to be at that little corner piece, that origin 0, 0. And I know it's going to have a slope, a consistent rate of change. And that can be written as an equation. Y is equal to mx, where m represents whatever my slope is. Okay? So taking a look here at this very first problem. Michelle's trying to make bracelets. She's got blue and red beads. And it says that the ratio of red beads to blue beads is going to be 3 to 1. So that means that every 3, what color? What does 3 represent? What color? Red. So for every 3 reds, we have 2 blues. Every 3 reds, we have 2 blues. So I'm going to write that down. So we have 3 reds, and we have 2 blues. So when I graph that, again, if I start at the origin, I'm going to graph where I see 3 reds, which is my x, and 2 blues, which is my y. So I'm graphing it at the point 3, 2. Now I can continue graphing. What's another point that would represent the ratio 3 reds and 2 blues? Ty? 6, 4. Good. 6 reds and 4 blues would be another representation of the same ratio. There's a third point that I can plot on here. Serenity? 9, 6. Good. So the graph of 9, 6. 9 reds and 6 blues. Okay, so we have this set up. We can go ahead and connect them. If I use a nice straight edge, I could connect them all together. And there's the graph of the relationship. It is a proportional relationship because it is going through the origin. I know it's going to have a slope because it is a straight line. So let's go ahead and identify what that slope is going to be. So we're taking a look at the rise over the run. So I know that I have to have a rise, which means I'm going up. And I can count it any which way. I could go from my origin to my first point. I could go from first point to second. I could go second to third. I could go from origin all the way to my third point. There's all sorts of different right triangles that I could create. Remember, we talked about that. You are able to create a series of right triangles by making a rise and connecting it with the run. And it makes all these little right triangles all along the line. They are similar right triangles because they'll have the same slope. Similar right triangles because they have the same slope. So I need to identify what that rise is going to be. So each one of these has a rise of how much? 2. Right? We're increasing from 0 to 2, from 2 to 4, from 4 to 6. We are increasing by 2 every single time. Every single time we are increasing by a rise of 2. Okay, then our run. Our run is 3. Good. Every single time we're moving to the right by 3. We're going from 0 to 3, from 3 to 6, from 6 to 9. Okay, so we're moving to the right by a series of 3s. Okay, and like always, we've got a positive over a positive. That equals a positive. And then 2 over 3 just stays 2/3. That's as simplified as it's going to get. So there's our slope. Our slope is 2/3. Okay? Now, I can write this in an equation format. Remember I told you guys before that you can write a proportional relationship as an equation. Y equals mx, and that's it. So we're going to write the equation. Y is equal to 2/3 x. For every 2 blues, we have 3 reds. That's what this represents. Your slope represents 2 blues for 3 reds. All right, let's take a look at the next problem. So we have a series of points or representations on a watch from Tanya, who was exercising for 30 minutes, but every 10 minutes she was checking her watch to see how many calories she burned. So we have at 10 minutes she burned 95 calories. That would represent 1 point, the point 10, 95. At 20 minutes it's 190 points, so that represents 20, 190. And then at 30 minutes, she burned 285 calories. So that represents those points. And remember, these are always going to be x comma y. This is your x, this is your y, this is your x, this is your y. So we can graph this. Now, before she ever started exercising, she was at 0 minutes. That means she was at 0 calories. So 0, 0, starting at the origin. Then we're going to go to our first point. We're going to go over to 10 and then up to 95. Now notice I don't have a 95 on my graph, do I? But I have to graph it as close as I possibly can, which means it's very close to that 100, just right below the 100 mark. And I'll graph my point. Okay, then I'm going to graph the next point, which is that 20, 190. So I go to the right to 20 and then go up to 190. Again, pretty close to that 200 mark. And then we're going to go over to where 30 is for the minutes, 30 minutes, and go up to around where 285 would be, a little bit above the halfway mark. And then we have got our graph. We can connect those points together, and it creates our line. Okay, and then from here we can go ahead and identify what our slope is. So we're going to find our rise over our run. Our rise over our run. Okay, so when I'm doing my rise over my run, I'm just going to start at my origin and go to my first point. Now remember, are we counting boxes or are we counting by the interval? By the intervals, not the boxes. Those boxes don't mean anything. It's the interval that matters, because each of these boxes going up represents how much? Each of these boxes going up represents 50. But each of these boxes going to the right does not represent 5. Each box, so every 2 boxes is 5. What's one box then? 2.5. Okay, so each box going to the right is 2.5. So you've got to be careful when you're doing your count. Your count is not counting boxes, it's counting the interval count, okay? So I know that every time I rise, I'm rising by 95. Okay, same thing here. If I go from this first point up to my second point, that is also a rise of 95. If I go from my second point up to my third point, that is a rise of 95. Okay, they each are increasing as a rise of a positive 95. Then I got to look at the run. We started at 0, and then we run all the way to what point? 10. Okay, then we went from 10, we run all the way to 20, so that's also a run of 10. Then we went from 20 all the way to 30, which is also a run of 10. So we're constantly running to the right by 10. And now we can simplify it. Now, you can leave this in fraction form, which is 19 over 2. And what this would mean is that for every 19 calories, you worked out for 2 minutes. Okay, for 19 calories, you worked out for 2 minutes. Or you can convert this into a decimal, 9.5. That's 9.5 calories per 1 minute. So either way would be fine. 19 calories for 2 minutes or 9.5 calories for 1 minute. It doesn't matter which one you decide to go with. And then, of course, we want to write it in our equation. Our equation being y is equal to, we'll keep it as a fraction. We'll put 19 over 2 x. So there's our equation. Now notice that my question has something else it wants to know. It says we're going to use the graph or even our equation to determine how many calories Tanya burned after 15 minutes of exercise. After 15 minutes of exercise. So let me ask you a question. Which one of these variables represents minutes? Is it the y or the x? The x. X represents your minutes. So what we're going to do, we've got this equation, y is equal to 19 over 2 times x. I can replace my x. I can substitute 15 minutes in for x. So I'm going to substitute 15 minutes for my x. We're going to substitute, in fact, I'll even write the words up here, substitute 15 minutes in for x. So I'm changing that x to the 15. So I now have 19 over 2 times 15, and that's what my calories will become. So when we multiply 19 over 2 times 15, we're going to get 142.5 calories. So after 15 minutes, she'll burn 142.5 calories. Okay, I want you guys to try the next one on your own. All right, let's take a look. Really? It was more than 10 seconds. Yep, it's 2 minutes. All right. Kevin's cereal has 3 grams of protein for every 1/4 of a cup. We're going to graph that relationship. So here we've got X representing the cups of cereal. We've got Y representing the grams of protein. We know that when he doesn't have any cereal at all, then he doesn't have any protein. So it starts at 0, 0. We know that when he has a 1/4 cup of cereal, so I'm going to go over to a 1/4 cup of cereal, he'll have 3 grams of protein. So I'll go up to 3 grams. That's where my first point is going to be. Okay, if I have half a cup of cereal, I'm going to have 6 grams of protein. If I have 3/4 a cup of cereal, I'm going to have 9 grams of protein. And that's the most that I'm able to calculate on my graph. So I can go ahead and then connect them. Okay, and of course it would continue to extend on. So we want to know, what is the slope going to be? So we're going to identify our rise over our run. So each one of these times that I'm rising by how much? 3. Right? Each one of these is a rise of 3. So I'm going to have positive 3 on the top. And then my run's a little bit different. Again, don't count boxes, count the interval. So I'm going from 0 to how much?
2.
You counted boxes, Juju. Don't count boxes. We went 1/4. Then we went from 1/4 to a half. Then we went from a half to 3/4. So we are moving, each time that we move, we're moving by 1/4. 1/4, 1/4. So it's positive 3 over a positive 1/4. Okay, now we got to simplify that. We're going to do 3 over 1/4. What do we get, Ryan? 12. Okay, so this represents 12. Now we want to state, what does it tell us? What does 12 mean? It's 12 what per what? Is it 12 cups per protein or 12 proteins per cup? 12 grams per protein. Per cup. 12 grams of protein per cup, right? Because it's the rise, this is our rise, y is our rise, it's rise per run. Okay, so x is our run, rise per run, so 12 grams of protein per cup. Now, we want to know how many grams of protein are there for 2.5 cups. So we got to plug it into that formula again. We get y is equal to 12x. We're going to substitute the x with 2.5 cups. So now we're going to do 12 times 2.5. When we do 12 times 2.5, we get what? 12 times 2.5. 30. 12 times 2.5, you're going to get 30 grams of protein. 30 grams of protein when you have 2.5 cups of cereal. Okay, now they want to know, what does the point 448 represent? So remember, when we write our points, we write them as, this is our x. So the 4 is our x. Remember, x is going to stand for cups of cereal. So this means it's 4 cups of cereal. 4 cups of cereal. And then the 48 stands for our y. So that's going to be 48 grams of protein. So when we have 4 cups of cereal, we have 48 grams of protein. That's just breaking this down little by little. Go ahead and flip it on over to the next page. All right. So we're going to go through this one real quickly. We have erasers. 2 erasers is going to cost us 80 cents. 3 erasers is $1.20. 4 erasers is $1.60. So the first thing I want to do is graph this. Again, I can start my graph at 0, 0, because if I don't buy any erasers, I don't spend any money. When I buy 2 erasers, I'm spending 80 cents, so I'm going to go 2, 0.8. 3 erasers, I'm spending $1.20, so I'm going to go 3, 1.2. And then 4 erasers, I've got $1.60. That goes from 4 to 1.6. And then, of course, I can go ahead and connect those in order to be able to create my vision of the line. All right, from there, we want to identify what the slope is going to be. So we have to identify our rise over our run. So let's just go from our origin to our first point. We're just going to create that triangle. Our origin to our first point. Who can raise their hand and tell me what is the rise going to be? Raising your hand. Go ahead, EJ.
0.8.
0.8. So we are increasing by 0.8. Then we need to find our run. Our run is going to be what? Who can raise their hand and tell me that? Juju? 2. Okay. This happens to be that each box was counting by 1. So yes, you would have it being a 2. Okay, then of course we always want to simplify. So 0.8 over 2 does simplify to 0.4. But if I wanted to put it in terms, because it says, hey, what does it represent? It's not just 0.4, it's 40 cents per what?
Eraser.
Per eraser. 40 cents per eraser is what it stands for, what our slope is going to represent. Now I want to know how much is it going to cost if I buy 10 of those erasers. So we take our equation. Our equation was y equals 0.40 times our x, and then we're going to replace x with the value 10. So we're going to do 10 times 0.40, and that's going to cost us how much? $4. It's going to cost us $4 to get 10 erasers. Okay, go ahead and do the rest of this page. Okay, taking a look here for the fair tickets. Who can tell me what the slope is going to be? What is the slope for the fair tickets going to be? Ryan, what'd you get? 5. Very good. So the slope would be 10 over 2 or just 5. And what does that represent? $5 per ticket. Good. So we have a rise. Each time that we are rising, we are going to rise by a rate of 5 over 1. It just happens to be that this increases by 10. If we checked the next one, we would go from 10 to 15 or to 25. That's an increase of 15. And then of course we would go from 15 to from 25 up to 35, which is increased by 10. So sometimes when it's pictured, it's not pictured exactly the same, but we do know that the slope along the whole line is always going to be the same. So let me just show that again. So these are creating different sized triangles. This is an increase of 10. This is an increase of 15. This is an increase of 10. The run, we have a run of 2, then we have a run of 3, and then another run of 2. But the rate is the same. 10 over 2 and 15 over 3 is going to come out to just 5. So we can do 10 over the 2, or you could do 15 over the 3. They all would come out to 10 or to 5. So that's $5 per ticket. Okay, now if we wanted to purchase 15 tickets, then how much would 15 tickets cost us, Serenity? $75. Very good. So if we take our slope of 5 and we have the equation y is equal to mx, and we replace that x with the 15, so we're just going to do 5 times the 15, then that would come out to y equaling $75. So it's $75 for us to purchase 15 tickets. Very good. Okay, so here, May is going apple picking, and she's choosing between 2 places. The cost of a crate of apples at each place is shown. We want to know which one should she go to. So basically, which one is the better deal. So she can buy 20 pounds of apples for $7.25, or she can buy $5 worth of apples, and it's 12 pounds. Which one's the better deal? Ty? The big one. The big one winds up becoming the better deal. Remember, we talked about unit price before, that all you want to do is you want to take your cost, $7.25, or in this case, you want to take $5, and you want to put it over your size. So we can put it over 20, or in this one, we put it over 12, and we want to see which one's going to come out cheaper. So in this case, this is going to come out to 0.3625. This one's going to come out to 0.416, and the 6 is going to repeat. So this is the cheaper price. Okay? So knowing our unit rates, our unit prices, those are all the same kind of concept, same idea. All right, let's go ahead and flip it on over to the last page. So we've talked about how to identify slope from a table, or sorry, from a graph. We've also identified slope in equation format. We're now going to focus on slope from a table and then comparing them. So you have to have an understanding of how to compare your rates of change or your slope, whether it's in a table form, an equation form, or from a graph. So when we are comparing it in a table format, it's still going to be rise over run. It just happens to be that your rise is where your y's are going to change, and your run is where your x changes. So you're focusing on those changes that are going to occur from one measure to the next. So let's focus on the rise first of all. We're starting at 40, and then we're going to 120. What is that? What's happening here? Are we increasing or decreasing? Increase, okay. So that's the first thing. We need to know that we're increasing, so it's going up. What are we going up by? 80. Good. Okay, now we're going from 120 to 240. Is that also increasing by 80? No, that's increasing by 120. I want to make note of that. That's a different increase. What about from 240 to 360? 120. And then 360 to 480? 120. Okay, so all of these are 120 except for the very first one, which is fine. Okay, then our run, we want to do the same thing for our run. We want to identify how is it changing. First of all, is it increasing or decreasing? Increasing, okay. We're going from 5 to 15. 10, good. We're going from 15 to 30. 15. 30 to 45. 15. And then from 45 to 60. 15. Okay, so here's the changes that are occurring. We're now going to identify the slope. So we're going to check our y's change, which was our rise. We have two of them. We have an 80 and we also have a 120. And then we're going to put them over our run, our changes of our x, which was the 10 and the 15. Doesn't matter which one we chose. They both come out to the same thing. They both will come out to 8. And it's 8 kilometers per minute. Always relate it back. 8 kilometers per minute. Okay, so that's the speed that this first airplane is traveling at. And we're trying to figure out which of these three airplanes has a greater or faster cruising speed. Okay, let's take a look at the second airplane here. The second airplane is just giving it to us as an equation. So what's the slope?
15.75.
Very good, 15.75. Remember, slope, it's that value m. Y equals mx. That m represents our slope. That means it's 15.75 kilometers per minute.
That was easy.
The equation ones always are. Okay, then our last one, we've got our graph. So we want to find our rise over our run. So we started at the origin. We had a rise of how much? From our rise up to our first point, it's a rise of 60. Our rise of 60. It has a run. Now remember, count your intervals. It has a run of going from the 0 all the way over to the right. What is it going? To the 4. It's going by 4. Okay? So 60 over 4 comes out to 15. That's 15 kilometers per minute. So we want to know who's got a greater cruising speed. The Boeing, the middle one. The Boeing's got the faster cruising speed. Okay, I want you guys to go ahead and do the same thing for the second problem. Identify the slopes of each situation, but this time you're going to find out which shop has the better deal, the best rate, meaning the cheapest price. Go ahead and do that. Okay, if we take a look at the very first one, we have a rise that's going up by 9, and then up by 18. Our run is going up by 1/4, and then by 1/2. You could do 9 over 1/4, or you could do 18 over 1/2. They both come out to $36 per hour. Okay, for the middle one, you have $98 for 3.5 hours. You just do 98 over 3.5. That would give you $28 per hour. And then for our last one, we have a rise of 50. And then we have a run of 2, so we would put 50 over 2, which comes out to $25 per hour. We want the better deal. That means the cheaper price. The cheaper price is going to be the rec place. Okay, we're going to go ahead and stop here. You do have a quizzes loaded online. You get 2 attempts. Please do not just sit there and try to skim through the first attempt real fast. You need to make sure you're doing both attempts correctly.